Hi, this is your Professor Sudha Kolathuparambil, section 3.1 Measures of Center. This section has 5 objectives: compute the mean of a data set and median of a data set and mode of a data set, and compare the properties of mean and median and approximate the mean with group data. Let us look at the first objective: compute the mean of the data set. The mean of the data set is the measure of center. If we imagine each data value be a weight, then the mean is the point at which the data set balances. And remember that the population consists of the entire collection of integer about which the information is sought, and the sample is actually a small group drawn from the population. So, the method for calculating the mean for the population and the sample both are same except for the notation. So, for population mean we usually represent using the notation mu. So, this is the symbol for population mean mu, and the sample mean, the notation is x and a bar. So, bar on top of the x. And the formula to compute the mean is add all the data and divide by the total number of the data. So, if you want to find the mean of these numbers, we will add these numbers and there are how many numbers are there? 1, 2, 3, 4, 5. So, divide by 5. So, add those numbers and divide by the number of data in that. Then you will get the value equal 81.2. So, the formula is add the numbers and divide by how many numbers. Assume these numbers are x1, x2, x3 like that. So, we can add those numbers like x1 plus x2 plus x3 plus up to, assume there are n numbers, so xn, and then we will divide that by n. So, this is the simple way to write that. This is known as the summation notation sigma xi, where I is varying from 1 to n. So, it will be x1 plus x2 plus, because I takes the value from 1, 2, 3 up to capital letter N, then we are dividing by n. So, this notation is known as the summation notation or sigma. Same way in the sample mean, assume the sample has n numbers x1, x2 up to xn. So, we will add those numbers and divide by n. During a semester, a student took 5 exams. The population of exam score is given here. Find the mean. So, mean is add all these numbers and divide by the divide by how many numbers are there. So, here 1, 2, 3, 4, 5. So, 5 numbers are there, or 5 exam it is given here. So, divide by 5. So, the mean is 81.2. Objective 2, a median of a data set. Median is another measure of center. So, if we get a data set, first we need to write those numbers in order, like starting from the smaller to largest, and assume if the number of data are odd, then the median will be the middle number. If there are even numbers in the data set, then the median will be the average of the two middle numbers, and median divides the values into two sets, or you can say split the data in half, and one half all the values will be greater than the median, and another half all the values will be smaller than the median. For example, here we have 5 numbers. 5 is an odd number, and the middle number will be, or the median is the middle number, that is 3. Here we have even number of numbers. So, in order to find the median, find the average of these two. That means add these numbers and divide by 2. That will be the median. So, median will be 3.5. In this example, 5 exam scores are given. We need to find the median of the exam score. So, first we will write these numbers in order, like starting from the smallest to the highest. Then find the middle number. Middle number or the median of this data set is 83, which divide the data into half. Let us look at another example. 8 patients undergo a new surgical procedure. That means there are 8 numbers. Then the median will be the average of the middle 2 numbers. So, first we need to write these numbers in order and take the average of the middle 2 numbers. While writing these numbers in order, I noticed that there are 2 13s. You have to include all the data in the data set. So, 12, that is the smallest, then 13, 13, then 15, 19, 20, 21 and 27. Then take the average of the middle 2 numbers. So, 15 plus 19 divided by 2, that is equal 17. 17 is the median. Let me explain you the procedure again. Procedure for computing the median is, first arrange the data values in increasing order and determine the number of data values, that is equal n. If n is odd, median is the middle number. If n is even, median will be the average of the 2 middle numbers. Objective 3, compare the properties of mean and median. A statistic is resistant if the values are not affected much by the extreme values. Extreme values means large or small values in the data set. The median is resistant, but the mean is not. So, let me explain you that with an example. 5 families have annual income, that is given here, and one family whose income was 25,000, they win a lottery and the income increased to 1,025,000. So, before the lottery win, the mean of these numbers will be 38,000 and median was 34,000. After winning the lottery, the mean changed to 238,000 and the median changed to 44,000. So, if you compare these values, you can see that the mean changed a lot compared to the median. That means median is not that much affected by the extreme value. Here the extreme value means this is too large value compared to all these. So, median is resistant, but mean is not. Mean is influenced by the extreme value. Remember that mean is the point at which the data set balances and median is the middle number, so that the half of the data set are less than the median and another half are greater than the median. So, when the data set is symmetric, the mean and median will be equal. When the data set is skewed to right, there are large values in the right tail because the median is resistant while the mean is not. The mean is generally more affected by these extreme values or the large values. Therefore, the data set is skewed to the right and mean is generally greater than the median. Similarly, when the data set is skewed to the left, there will be small values in the left tail and the mean will be affected too much with this extreme values. So, mean will be on the left side of the median, that means mean will be less than the median because median is resistant, but mean is not. So, now what do you think, which is the better measure, mean or median? They both measure the center in different but appropriate ways. When the data are highly skewed, some people prefer to use median. However, mean is still an appropriate measure of center, and it is sometimes preferable over when the data are highly skewed. These are the advantages and disadvantages of mean and median. While calculating the mean, we consider all the values in the data. And disadvantages is mean is highly influenced by the extreme values. Advantage of median is it is not much influenced by the extreme values, so because it is resistant. And the median disadvantages is it depends only on the middle value or the middle number. Objective 4, find the mode of a data set. Mode of a data set is the value that appears more frequently. If two or more values are tied for the most frequent, they are all considered for the mode. If all the values have the same frequency, then that data set has no mode. In this example, we need to find the mode. So, if you count 1 appears more than 0, 2, 3 and 6. So, 1 will be the mode. Mode is sometimes classified as a measure of center, but it is not really accurate because mode can be largest value in the data set or the smallest or anywhere in between that. Mean and median can be computed only for quantitative data. That means if we have numbers, then only we can find the mean and median. But we can find the mode for a qualitative data because we can look for the most frequently appearing category. So, in this example, we need to find the mode. So, you can check how many times Honda appears here and how many times Toyota. So, count like that and see which one occurs the most, and Toyota appears 6 times. So, Toyota will be the mode. Objective 5, approximating the mean using group data. Sometimes we do not have access to the raw data in the data set, but we were given a frequency distribution. So, in that case, we will compute the midpoint of each class, then multiply the midpoint with the frequency, then add all those and divide by the sum of the frequencies. This table represents the number of text messages sent via cell phone by a sample of 50 high school students, and we need to find the mean number of messages sent. First step is to find the midpoint. Midpoint of the first class is add the lower limit of these two classes and divide by 2. Midpoint of the second class is add these two and divide by 2. Continue the procedure until we get the midpoint of all the classes. So, for the last class, you need to look for the lower limit for the next class also in order to get the midpoint. So, this will be 300. So, 250 plus 300 divided by 2. So, I find the midpoint of each class. Now, I need to multiply the midpoint with the frequency. I multiplied each one by the corresponding frequency. Now, add all these, then find the sum of the frequency and divide. Sum of the frequency is equal 50. So, divide the sum by 50 to get the mean. In this section, you learn how to find the mean, median and mode. You learn the definition of resistant, median is resistant, mean is not. Also, how to approximate the mean for a group data.